Okay, let's do the question number 13, which is the organism which exhibits very nearly the characteristics of an ideal pathogenic indicator is, there are 4 options in which the correct option will be option B, which is Escherichia coli. Why Escherichia coli? Because see, there are other options: Entamoeba, Histolytica, Salmonella typhi, Vibrio cholera, but these options are not viable because Escherichia coli is the ideal pathogenic indicator used for bacterial analysis of water. It is used for bacterial analysis of water. See, it is a fecal indicator. It indicates the presence of fecal contamination. So it is a type of bacteria that lives normally in human intestine, and it also found in the gut of some animals. Most type of E. coli, we can call it E. coli as well. Most type of E. coli are harmless and even help keep your digestive tract healthy. They are harmless, they are good for us, but some strains can cause diarrhea if we eat contaminated food or drink foul water. So, Escherichia coli, it's itself harmless, but the presence of this bacteria may indicate that we can have some serious contamination into the water. So it is the ideal pathogenic indicator to check if there can be other pathogens in water or not. So the option is option B. Now let's move to question number 14, which is the results of analysis of raw water sample are given below. Turbidity 5 mg per liter. They have given us the turbidity 5 mg per liter. Let's highlight this: 5 mg per liter. pH 7.4, fluoride 2.5 mg per liter, total hardness 300, iron 3 mg per liter, MPN 50 per 100 ml. Okay, now we have to check what is needed to be removed. So from the data given above, it can be inferred that water needs removal of what are the things that should be removed from the water, what are in the safe limit and what should be removed. So I have discussed in previous lectures about the specific parameters of water and their acceptable limit and permissible limit in absence of any other alternate source. So here see, turbidity acceptable limit 1, but we can manage with 5 as well, right? So 1 to 5 is okay, turbidity. And next is pH value. They are asking pH is 7 to 8.5 and we have the pH 7.4 in the question. This is also good. Then fluoride content should be equal to 1. It should be, acceptable limit should be 1, can go up to 1.5 but not more than that. So 1 to 1.5. And fluoride content is also given 1 milligram per liter. So fluoride okay, pH okay, turbidity they have given 3.5 NTU, this is also fine. Now we have iron. Iron limit is 0.3 and there is no relaxation. That means less than 0.3 is only the only option we can say. So iron, but they have given in the water iron is 2.7 milligram per liter. So iron is not acceptable. We need to do the removal of iron. And then total hardness. See, total hardness 200 is the acceptable limit. But in any other sources it can go up to 600. So 200 is the acceptable and we have given 350 milligram per liter. So hardness should also be removed. 600 is the case when there is no alternate options. For hardness, let's consider that there is no other, there are other options, but acceptable limit is 200. So if we see the question, the options that match, we have turbidity into the limits. Turbidity okay, turbidity is okay, pH okay, fluoride not okay, to iron not at all okay, MPN we have to remove. We don't want any bacteria, there is no relaxation of bacteria into the water, so it will always be removed. Bacteria, any pathogen we don't need. So there will be a disinfection process, definitely, because we don't want any pathogens, right? Now the best option that matches is, see, iron followed by disinfection, fluorides, hardness and iron followed by disinfection. No, yes, the option will be hardness, iron followed by disinfection. This is the perfect, because fluoride is also higher limit, right? So fluoride is also greater than 1, so it is 2.5 fluorides, and then hardness is also removed. See, fluoride and disinfection is all very necessary in this question, and fluoride and disinfection are not both in these three options, so only option left is option number D, so it is the correct answer. Now question 15, in natural water hardness is mainly caused by what things? So see, hardness is caused by the presence of carbonates, bicarbonates and sulfates, chlorides of what? Of calcium and magnesium. Calcium and magnesium, we can say aluminium sometimes. These are all multivalent cations. Hardness is never caused by any single valent cations. For example, sodium Na+, hardness is not caused by this, and potassium K+, hardness is not caused by this as well. We need multivalent cations, Al3+, so these things will work. And also they are carbonates, bicarbonates, sulfates and chlorides only. And so in natural water hardness is mainly caused by, we have the option calcium and magnesium. Mainly means generally it is caused by calcium and magnesium. So option number D. Next is temporary hardness in water is caused by the presence of, see, now just now we said we studied about hardness, right? Now temporary hardness. So the temporary hardness is caused by the presence of bicarbonates. Presence of bicarbonates. So this bicarbonate only, this will create what? It will create the temporary hardness. Only by bicarbonates. Bicarbonates can also, it is written as SCO3 minus. Okay, so it is SCO3 minus. So the option will be bicarbonates and other things, carbonates, sulfates, chlorides will give you the permanent hardness. So only bicarbonates of calcium and magnesium will give the temporary hardness. Next is blue baby disease. Methemoglobinemia in children is caused by the presence of, see, the blue baby disease is caused by the presence of nitrates. It is caused by the presence of nitrate. See, nitrate limit is 45 milligram per liter. In absence of any alternate source also, it is 45 milligram per liter. If there is slightly greater value of nitrates, it will cause blue baby disease. See, nitrate will, what is blue baby disease? See, nitrate sucks out all the oxygen of the water, right? So if small babies have this water, they don't get proper oxygen supply in their body because nitrate is there, it is just sucking out all the oxygen. So the babies are not able to breathe properly, they suffocate and they turn bluish, that because they don't get the proper oxygen intake. So only this disease is named as blue baby disease, and the scientific name is methemoglobinemia. So the answer is nitrates. Now 18. The microbial quality of treated piped water supplies is monitored by, see, microbial quality of treated piped water supply is monitored by, we have only one option, that is coliform MPN test. Coliform MPN test they do to check if there is any E. coli bacteria colony. If it is present, just because it is indicator of any pathogen, so they will be just ready that yeah, there can be any pathogen. So coliform MPN test is the most suitable test. Now next question is excessive fluoride in drinking water causes, see, if there is excessive fluoride greater than 1, we can say milligram per liter, or max to max 1.5 milligram per liter, there will be mottling of teeth, bones will be brittle, teeth will be brittle, there will be mottling. So the option will be option B.